So in the previous sequence of videos, we learned about the equilibrium model. Now we want to talk about a second model that we can use even if our object is not in equilibrium. That is the constant force model. So the constant force model is simply where the net force is constant. And usually what this means is that every single one of your forces also, etc., are constant. If every single force is constant and you add them up, then the net force is constant. Now, what this relates to is the idea that if your forces are changing in time, then we have a much more complicated situation to deal with. We will learn some techniques to do that if our force depends on position or on time, but we're not dealing with that right now. So, what happens here? We have uniform acceleration. Why? If net force is not changing, acceleration is not changing. And then we get to say that acceleration and net force are in the same direction. So we then get to use kinematics of constant acceleration. Remember, this was one of our models in kinematics. So when can't we do this? Well, if the forces aren't constant, which means the forces are depending on either time or position, then we need to do something else. So again, right now we're not talking about what that thing might be because we're just learning to do some type of force problems. We're going to be working with the simpler ones. So just as there were situations where you assumed that acceleration was constant because you weren't told otherwise and that was the only way you could solve the problem, similarly here we're going to assume that forces are constant since otherwise we can't solve the problem. There's a really important connection that I want to explicitly draw for you, that we had two kinematics models, uniform motion and constant acceleration. So uniform motion was when your change in velocity equals 0. Now, equilibrium is when your change in velocity equals 0. And we've said that F net equals 0. So these models are basically the same, except that this one, the top one, equilibrium, uses forces, and the bottom one used kinematics equations. Similarly, we had constant acceleration before, and now we have constant force. So those are really the same models, except that these are forces, and the bottom ones were our x, v, a. So the things that are going in your equations are different, except for the fact that the top one also has acceleration. So acceleration is what you use to tie these together, but you actually have matched models in both of them. So right now, the things we've learned to deal with are either uniform motion, which is the same statement as equilibrium, or constant force, which results in constant acceleration. When we want to deal with motion that doesn't match one of these, we're going to need to use techniques that we will meet in future chapters.